Hello everyone. Today we're going to learn the lesson 18.2, defining and evaluating the basic trigonometric functions. You will be able to use special right triangles in a unit circle. In the previous lesson 18.1, we have learned about the different types of angles and how to find coterminal angles, how to convert angles from degrees to radian mode, and vice versa. So in day one today, we're going to be using special right triangles in a unit circle, and you're going to be labeling sine, cosine, and tangent in right triangles drawn within a unit circle. Let's start with a review. So in geometry, you should have learned that sine, cosine, tangent are ratios of the lengths of the sides of a right triangle, such as the one that is labeled below. If theta is an acute angle in a right triangle, then the sine of theta is equal to the side that is opposite over hypotenuse. So that would be B over C in this case. And so opposite side is B and hypotenuse side is C. So sine is the opposite over hypotenuse. And so the ratio is opposite of hypotenuse. Some of you also remember SOHCAHTOA. So if you remember sine, cosine, and tangent ratio using SOHCAHTOA, it's great. Otherwise, you can just learn as you go on. The cosine of an angle is given by the adjacent side over the hypotenuse side. So therefore, it is the adjacent side over hypotenuse, which is A over C, and that satisfies the condition for a cosine ratio. And then next, the tangent ratio is given by opposite over adjacent. So therefore, it is B over C, and that is basically all of the sine, cosine, and tangent, the three trigonometric ratios. Next, we're going to take a look at another review, which is the two special triangles. There's a 45, 45, 90, and also a 30, 60, 90. Those are both special right triangles that you should have learned about in geometry. The ratios of the sides, or the relationship between the sides of a 45, 45, 90 is that the side A, if both of them are actually the same because it's isosceles, should be the hypotenuse is the radical 2 times the short side. So radical 2 times side A. For example, if you're given that one side is A is 5 and the other side should be 5 also, then the hypotenuse is going to be 5 radical 2. And that's it on the 45, 45, 90. Let's take a look at the 30, 60, 90. There are three different sides here, 30, 60, and 90, because all three angles are different. So the side that is opposite of 30 is the shortest side, so we call it S. And the long side is L, and the hypotenuse is H. The hypotenuse is twice as long as the short side, so therefore hypotenuse is 2 times S, or 2 times A in this case. And the long side is going to be radical 3, so it's A times radical 3. So let's give a quick example. If the short side is 4, then the longer side is 4 radical 3, and the hypotenuse would be the length of 8. So that's a perfect example of how the three sides are related. And it always goes back to the short side, having a relation between the long side and hypotenuse. So hopefully you remember those two types of triangles, and you're saying, yes, this rings a bell from geometry. If not, you will pick it up along the way. So let's continue and get on with our unit circle. And we're going to inscribe the 45, 45, 90 triangle inside a unit circle. And so we're going to take a look at the triangle. It's already labeled. Let's backtrack a little bit and begin by reviewing again. This is the 45, 45, 90 triangle. It's the same one that is inscribed here. Let's go ahead and label the sides using what we know earlier as the ratio. The most basic side is going to have the side of 1, and then the hypotenuse is going to be radical 2. So that is how it's related. Remember, the short side and the hypotenuse. Hypotenuse is radical 2. The short sides are 1 and 1. So It's an isosceles triangle. Now let's go ahead and move on and find the sine of 45 degrees, the same way that we just did earlier. So the sine is opposite over hypotenuse, which means opposite is 1. And so hypotenuse is radical 2. And in math, there is a rule that says we cannot have radical underneath the fraction. So we need to rationalize this by multiplying a radical 2 on top and bottom of the fraction. So we're going to multiply top and bottom by radical 2. And on top, we have radical 2 times 1, which is radical 2. On the bottom, 2 radical 2's make a 2. So that is why the answer is on the right-hand side, the same thing, labeled radical 2 over 2 for sine of 45 degree. I'm showing you the work of how they got it. The cosine of 45 is actually the adjacent side, which is also 1, over hypotenuse, which is radical 2. And so again, it's the same rule that applies. We need to rationalize it by multiplying by radical 2 on top and bottom. And therefore, it is radical 2 over 2 again. And so that is the cosine. Again, the work is the same. For the tangent of 45, it is the opposite side, which is 1 in this case, over the adjacent side, which is also 1. So we got 1 over 1, which is 1. So that gives us the tangent of 1, which is the same exact answer that is written here. And let me just rewrite that. So the next thing we're going to do is take a look at this triangle, and we're going to draw various types of triangles reflecting it across different lines to see where the position of this triangle may lie within this unit circle. So right now we're seeing that this triangle is drawn in the first quadrant, quadrant 1. We're going to take a look at what this triangle is going to look like in quadrant 2, quadrant 3, and quadrant 4. So the direction says sketch the resulting, number 1. We're going to, again, take a look at the 45, 45, 90. Step 1, sketch the result of the reflecting the triangle across the y-axis. So the first one we're going to do is reflect the existing triangle over the y-axis. So let's take a look at what that looks like. So again, the right triangle is reflected on the, let's go ahead and review this again. We're going to sketch the triangle across the y-axis. So let me clean up the board a little bit. We're going to go back to the unit circle, and we're going to now inscribe the triangle by reflecting it across the y-axis. And now the circle is clean. Let's go ahead and draw the y-axis. This is the y-axis. We're going to reflect that triangle across to the other side. And so let's take a look at what that may look like. So it should look something like this. And therefore, the coordinates of the different points right here is going to be basically the same. So the values of sine, cosine, and tangent are not going to change because it's the same exact triangle. So the sine, again, is going to equal to radical 2 over 2 because it is still the opposite side over a hypotenuse. So we have the same value in quadrant 2. The only thing that is going to be different is that the sine for the cosine, it's going to be different because we're going to the left side now, and everyone knows that moving to the left is going to give us a negative. So instead of it being radical 2 over 2, it should be negative radical 2 over 2 because that coordinate point is going to the left and then up. So left is negative, up is positive. And let me just go ahead and fill out the coordinate for the first quadrant. So notice that they are both positive. And then the one on the left side is negative, positive. Next, we're going to sketch the result of the reflection across the x-axis. So we're going to reflect these two triangles across the x-axis. Let me clean it up first. And then let me go ahead and draw the x-axis line right here. So we're going to reflect it across this line. And so you should expect to see a couple of triangles drawn on the bottom. And so the coordinates of these are going to be exactly the same, the values, except the sign is going to be different. This one we're going left and down, so it should be both negative. So both of them should be negative. So again, the values will be the same, but the sign is negative, negative. And then this one across the other side is the same thing. We're going to the right and down, so it should be positive, negative, right? So the coordinate is going to be positive radical 2 over 2, and then negative radical 2 over 2, because we're going to the right and then we're going down. So there you have it, the 4 special coordinates involving a 45 degree in quadrant 1, 2, 3, and 4. Notice that the first number is called the cosine. Then the second number is sine. So in every quadrant, the first number is always cosine and the second is always sine. And it's easier to remember that it's alphabetical C than S because it's X before Y. So therefore, you can remember it the same way that I usually do. So cosine and sine. Remember, because vertical is the Y coordinate. So that's the sine, because opposite of the angle is vertical. And we just finished the last one as well. So we're done reflecting all 45, 45, 90s. And let's take a look at take a note that there should be a triangle in each quadrant, right? So we're going to continue this pattern, and we're going to involve a 30, 60, 90 again by finding the sine, cosine, and tangent of a 30, 60, and 90. So let's focus on the 30-degree angle for now, because this is this triangle has both 30 and 60. So let's work on the 30-degree. So the opposite, sine is opposite over hypotenuse. Let me go back and label the sides of the triangle. In the most basic type, the shortest side is opposite of 30 degree. And we're just going to give it the length of 1. The longest side is the hypotenuse, and that is going to have, and the length is going to be twice as long. But the longer side is going to have radical 3 times as long as the short side, so it is radical 3. And the hypotenuse is twice as long, so it is going to be 2. So those are the lengths of the 3 sides of this triangle. And now let's go ahead and proceed with finding the sine of 30 degree, which is the opposite side over hypotenuse. Opposite is 1. Opposite of 30 has a length of 1. That's the short side. Over hypotenuse, which is 2. And so that's 1/2. So the sine of 30 is 1/2. The cosine of 30 degrees is equal to the adjacent side. Adjacent is radical 3. So adjacent is next to 30 degree, and that will have the length of radical 3 over hypotenuse, which is 2. So that's radical 3 over 2, which is what we have here. And then finally, tangent of 30 degrees. So finding the tangent is the ratio, which is opposite over adjacent. So it's going to be 1 over radical 3. So the tangent of 30 degree again is 1 over radical 3. And again, we have the same rule that applies. We cannot have radical underneath a fraction. So we're going to rationalize it by multiplying by radical 3 on top and bottom. And then on top, we will have radical 3 times 1, which is radical 3. Over on the bottom, we have radical 3 times radical 3, which is 3. So that's how we have the answer is radical 3 over 3 for tangent of 30 degrees. And those are the sine, cosine, and tangent for a 30 degree, which is in first quadrant. And we're going to pretty much take a look at the next step, which means we're going to follow the routine, and we're going to sketch those reflecting triangles in across the y-axis and then x-axis. So again, we're going to have 4 triangles all together. So let me clean up the board a little bit first. And yeah, let me clean up the board. So I have the y-axis right here. The line, the triangle that is reflected across the y-axis is going to look like this: 30, 60, 90. Again, the ratios, the lengths are 1, 2, and radical 3. And then if we find the sine of 30 degrees, it will give us the same value, which is opposite over hypotenuse, that's 1/2. So we're going to label the coordinate. Again, the difference between the coordinate is we're going to the left and up. So we should have left, which is negative 1/2, because we're going left and then up. So the coordinate for the sine is going to be still positive because we are not going anywhere. It's going just up right now. So for the sine, it's positive. But cosine, we're going left. So it is radical 3 over 2, but it's negative radical 3. So the answer is going to be negative because we're going to the left. So that should be a negative right there. And so we're going to label the coordinate with negative radical 3 over 2 because it's cosine first, and then sine, which is 1/2. And those are the same values that we have on the quadrant 1. So that is the value of sine, cosine. And then this is in quadrant 2. So next we're going to sketch, let's finish finding the tangent of 30. So the tangent of 30, you can also think of it as sine divided by cosine, or y over x, which means it's 1/2 over radical 3 over 2, but the cosine should be negative. So when you get the answer, it should be a negative tangent. Or you can use the same ratio, which is opposite over adjacent for the tangent. You're going to get the same answer. Dividing by the fraction is multiplying the reciprocal, so you end up with 1 over radical 3. Or like I said, and that will turn into radical 3 over 3. Or you can use the ratio of tangent, which is opposite over adjacent, which is 1 over radical 3 right away. And you rationalize it, you will get the same answer. So both ways, you will get tangent, which is radical 3 over 3. And it should be negative because the cosine is negative. So it should be negative. So we're going to finish, continue the pattern and finish reflecting the triangles over the x-axis. So we will have a total of 4 triangles. So let me clean up the board here again. All right. So we're going to continue and we're going to reflect it across the axis. And that is what it's going to look like across the x-axis in 3rd quadrant and then in 4th quadrant, the same thing. And we're going to label the coordinates, which will give us the same values as what we found earlier, except this time we're going left and down, so it should be both negative. So negative radical 3 over 2 and negative 1/2. And then the same thing in the 4th quadrant, we're going to the right and down, so it should be positive and then negative, so it should be 1/2. I'm sorry, it's radical 3 over 2 and then negative 1/2. So that's the values for 30, 60, just 30 degrees in the 4 quadrants. And we're going to take a look at the 60 degree next. So we're going to follow the same routine that we just went through for 45, 45, 30, and now we're going to do 60 degree. And it's going to be the same quadrant. So the tangent is the one that is going to be changing the sign. So just the tangent is going to be negative in quadrant 3 and quadrant 4. Actually, in quadrant 2 and quadrant 4. So here is the 60 degree, and we're going to reflect it the same way. So if you can see that we're reflecting 60 degree all the way across the x-axis and the y-axis, this is what you will see in the resulting 4 quadrants. So you will see that you following the same formula. Opposite over hypotenuse is radical 3 over 2 for sine. And then the cosine, so again, the sine of 60 degrees is opposite, which is radical 3 over 2. Then the cosine is going to be adjacent over hypotenuse, which is 1/2. And then tangent is opposite over adjacent, which is radical 3. So there you have the sine, cosine, and tangent values for all 3, for all 60 degrees. And let's go ahead and label the coordinate. This should be cosine and sine. So it's 1/2 radical 3 over 2, and then going to the left is negative 1/2 and up is positive. And then going on the bottom left is negative, negative, and then going to the right is 1/2 positive and negative. So the values are all the same. And then, so that's for all three types of triangles, 30, 60, 90, and then 45. And we just went through labeling everything. So here's a quick review. I already mentioned this before. The cosine value is the x value. The sine value is the y value. And so the tangent value is going to be, and so yes, it's alphabetical, cosine before sine. And then tangent value, some of you may know, it's the y value divided by x value. So it is y over x. So it's sine over cosine, which is tangent. And there's a summary right here, of what we just went through right now. We just went through and finding the values of 45, 45, so 45, 30, and 60. So here are all the 45 angles, the values. You can see that it's all positive in first quadrant, and see how the sign changes in every quadrant. Here is the 30 degree. Let me change a different color. So here's the 30 degree. And you can see that the sign, again, in quadrant 2, it is negative, positive, and then quadrant 3, both negative, and quadrant 4 is positive, negative. And then here's 60 degree. Again, the signs follow the same routine. And there we cover pretty much all of the special angles involving the sine, cosine, and tangent. And that's pretty much the end of the lesson for today, for day 1. Sorry it was a long lesson. You may go ahead and begin your assignment for today.